Hello, students. These are recordings about sequence diagrams. I will try to make it rather short, but there will be a couple of them, and not all of them related to my slides. So this one is just a formal lecture about a couple of slides we have on the canvas. I'm trying to share the screen with you, and here we are. Sequence diagrams as a part of object-oriented analysis and design. These diagrams are practically have been unchanged since they were included in UML. Unchanged in terms of their format, how they look. At the top row, we have objects, and we have timeline for each object, how each object lives its life throughout your modeling. And because they were included in UML very, very early, they 100% follow the ideas of object-oriented programming languages where objects pass a message to each other. So object passes a message to another object. This is in certain sequence. So there is a timeline. So at the top of the diagram is the first message. The more you go down, 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 towards the bottom of the diagram is the last message to be sent between the objects. So this means that actually class diagram has to have at the top row objects, okay? Objects. Let's see now exactly what is in this slide. There is a definition what a sequence diagrams contains of elements and notation. We focus on message passing, but there is one thing which is not practically included in any book properly, is this how to produce a sequence diagram. And I will have a separate notes on that with video lectures. Then we have to compare the sequence diagram against class diagrams, and we have to finally look at correlation between use cases, sequence diagrams and class diagrams. These three diagrams are essential, and we practically don't need any other apart from the extra one, which is component-based diagram. Okay, so it's the whole idea for people who are very familiar with object-oriented programming is here. We have classes and the instances in object-oriented world. They collaborate by sending messages, and this is quite important, you know. This is one of the basic principles of object orientation. That it means that when a class sends a message to another class, excuse me, that's object sending a message to another object. But you know, objects are conceptualized into classes. So people sometimes take liberty and they say class sends a message, but actually it's always an object sending message to each objects, sending messages to each other. So this is kind of called dynamics of your software under development. So very often when we looked at the class diagrams and associations between classes and multiplicity, one to many, many to many, and so on, this is kind of a static aspect of your software. Don't ask me why is this static and dynamic, but before we started having object orientation on our plate, we never had any idea of messages passed between objects. Didn't exist. The only thing we had is a static relationship between these modeling objects that belongs also in the database world, in database modeling, between entities and the database, future database element. So this message passing is typical of object orientation, but please don't confuse it with this kind of class collaboration. So the message passed between the objects, don't confuse it with class associations. These are two completely different things. They are not related to each other. Okay, so when you model one, by no means you are modeling another. More precise, objects pass messages, and therefore, if we wish to show dynamics, we need to find object and identify which messages are passed between them. That's not very difficult if we know if you know exactly that there is a next step in software development in implementation, and implementation will be in object-oriented programming languages, from that perspective, sequence diagrams are very, very natural representation or picture how messages are passed between the object. And these are sequences of messages. Sequences, you know, they go in certain sequence. They are synchronous, asynchronous, you know, a lot of things there. However, so far, as far as I can see, we haven't connected use cases and class diagrams at all. Now we are jumping on sequence diagram and we say, well, we need objects. For the use cases, we need use case diagram, we need use cases. For class diagram, we need classes. For sequence diagram, we need objects. So where are they? You know, really, we are trying very hard to find these main building blocks. But as far as I know, nobody is telling us how to find these objects. Nobody was telling us how to find classes. We simply cannot have any methodology which can help us with that. So notation is very often, it's classical notation. You have objects at the top. We will show a couple of diagrams later. Objects at the top. Each object has a lifeline, a line which goes from the objects down, down, down. That shows how long the object is alive. Because you can close the object, you can kill the object, you can just make it not active anymore, and so on. And then messages are passing between two objects by connecting lifelines. And you always go from left to right and from right to left messages, because messages can be passed in between many, many objects. Yeah. However, the essence of sequence diagrams are these messages. But if you don't have objects, you don't have messages. So actually, the main problem is to find objects. When you find them, messages are not an issue. So there are this is not easy to find. Classes are not easy to find. Objects are not easy to find. Whoever tells you that it's kind of goes just naturally, that's not true. You know, even classes are difficult to find. Some classes can have so many attributes, and some of these attributes can become classes. Association can become classes. I haven't covered all these things, how complicated this can become. So where are the objects? These are called abstractions, available in use case description. So actually you do need a description for each of your use case. If you don't have a written text in natural language, Norwegian, English, any language, you don't have a use case. But you know, we are cheating a little bit by having very simple examples where text is not very rich. If we miss some meaning or semantics, then we make up things, we add things. But in principle, abstractions are very difficult to find, and software development works with abstractions only. There are various types of objects, UML says. And UML is telling us that's what they were telling us was really very early. UML was extremely advanced 25 years ago in the way of thinking and the philosophy they wanted to sell. This is why they are still alive. They were telling us there are various types of objects. Some of them are objects that represent user interfaces. This is our famous screen. Remember, 25 years ago, we didn't have mobile and wireless technology. We didn't have touch screens. We could only hardly click. We didn't have even scroll bars. Okay, it started developing, you know, in parallel with UML, but that wasn't our reality. Okay, it was a completely different world compared to today. There are three types of objects which UML is suggesting. One type of object is the object which is associated with your user interfaces, with screens, displays, something like that. Second type of objects are objects which are associated with control of something, you know. The word control is so wrong here, but I haven't got any other, so I have to use it. But to be honest, we used control word for a decade, until we started simply saying, well, that's your future computer program that will take some data, compute, display something on the screen, take information from the screen. Well, a typical construction for any software application. And then the objects will just store data, nothing else but data. And this is what UML says, 3 types of objects. So you're not in a position to argue against that. You can have only 3 types of objects and forget everything else. You are not in C++ programming. I used to talk about message passing for about 45 minutes 15 years ago. Today, I have to tell you something which is quite unpleasant, but we are not particularly concerned with messages that we need to find out exactly what they are. We can approximate them. And you can say from which object is message sent to which object, okay? But to have a full signature of the message and the definition with attributes, parameters, whatever you call it, it's kind of not being important anymore. So one of the most important part of sequence diagram is to manage message passing, and then suddenly we are not interested in it. So what are we interested in? We are interested in the choices of objects at the top row of sequence diagram. Whether something is asynchronous or synchronous can be noted on the sequence diagram. But today, in the time of cloud and edge computing in parallel, in the fog computing, Drew, and I don't know, dust, computational dust. I said, Drew, no, it's dew. This as small as dew, which appears in the morning on the leaves of the plant. Even that exists in the vocabulary of computer scientists. I'm not quite sure that synchronous asynchronous plays any role, and plus touch screen interaction from the user. Very, very rarely you have to elaborate exclusively on that, but it exists. So I won't talk much about messages, because the biggest problem also is to find objects. So there is no prescription of how to create a sequence diagram, but this is something quite common. People do that. We have been doing this for 20 years. Find objects only from use case descriptions, from nowhere else. Could you please remember this? You have to have a use case description in front of you. Eliminate redundant objects. You know, it's a natural language. We have synonyms, acronyms, words which mean the same thing but just look different, and the other way around. So eliminate everything which causes confusion. Then categorize these objects into user interface, control, and other objects. Now, UML wants you to do that. You have no choice. Do not argue against that. So if you have ever learned sequence diagram differently to be ready for object-oriented programming languages, you will struggle now. You have to divorce yourself from any of these ideas that classes are just gathering together, their objects sending messages to each other. Maybe from these messages you can create operations in the class compartment which conceptualize the object. All is possible. But in principle, you must have user interface object. You must have an object which is called control, which is your future computer program, and anything else. You will define the live lines, and you can read, you can understand these message passing and draw really like lines from one object, lifeline of one object to the lifeline of another object. So let's have a look at a few examples. All right.